Okay, I'm here today with Clemens Dransfeld. You're your full professor in our faculty. Can you introduce yourself a little bit to the students?
Well, thanks a lot. First, thanks a lot for being invited to have a chat with you. I come from Switzerland. I've been 35 years in Switzerland, and about 2 years ago I moved to the faculty. My background is material science and industrial design. I've been 15 years in industry and then 10 years in academia in Switzerland. And now I'm professor for aerospace manufacturing technologies, and I'm mainly interested in manufacturing processes for composite materials.
Okay, well, today we're not going to talk about composite materials and manufacturing.
No.
Now we want to take a bit more important topic. Well, maybe not important, but another topic. Today I want to talk about design thinking, because we talk about the design and synthesis exercise, where we, in a design process, synthesize previously acquired knowledge. But it also has a creative part in there, because you need to come up with concepts, etc. So can you introduce the concept of design thinking to us?
Yeah, so design thinking is, let's say, in some way the methodical approach to the creative process. And design thinking comes out of the creative trades, from industrial design and applied art and these things, and advertisement and these industries. And it is basically an approach how you deal with the creativity in the work when it is requested. And it is basically, and the origin from design thinking is really from these trades, from these disciplines who have to be creative all the time, where the creativity is the key output. But nowadays we see design thinking in all kinds of industries, all tech industries, where innovation is important, have implemented in some way or in another design thinking in their innovation processes.
Okay, so it is about being creative. Is it being forced to be creative, or is it still your brain sparks you can put in the process?
It is there's a couple of elements in design thinking, which in the different design thinking schools, which are common. And one element is which is called to empathize with a topic. So maybe in real analytical engineer, looks at the problem, analyzes the problem, dissects the problem and sub-problem, solves the sub-problems, and then puts it together again. In design thinking, you follow a completely different approach, that you are, before doing the actual work, you play. And this is called discovery. So you become acquainted with the topic, and you become, in a very empirical way, you become acquainted with problem-solving approaches, which are more holistic than segmented.
Okay, so this is not only applicable to the creative art, so to say, but also to an engineering design.
Yeah, and I think it becomes in particular interesting when problems are not so well defined. Imagine you're asked to design an aircraft, and the aircraft is maybe just the derivation of a previous aircraft. It's a fixed-wing aircraft. Maybe the payload is a little bit higher. Maybe the engine is a newer generation engine, and so on. In this case, the standard, let's say, engineering school or also systems engineering approach is very powerful because it allows you in a very structured way to approach the problem, and you avoid to overlook anything, so systems engineering is very complete, it's kind of bulletproof, that's the strength of it. But if you have a problem where almost nothing is known, and where you can expect that the requirements have been set by people who also don't know, and because of that the problem is maybe only partially defined, or it is ill-defined, which is even worse. So basically, you have a problem where there is actually a priori not a solution. This is when design thinking is really powerful, because it allows a synthetic approach. You kind of like approach the problem in an intuitive, playful way. And this initial phase of discovery allows you to explore what are actually the requirements you need to know to do the real development.
Okay. Let us now try to make it a bit more concrete. Can you just, based on your experience, run us through a process? How does it really work?
Yeah, so my own industrial experience as a product developer was the following. First is I realized, or it is based on the hypothesis that the customer is mostly not competent to properly define an assignment or a project request, And
how do you communicate that to the customer that he or she doesn't know what she's doing?
Let me explain you. Okay. Yeah, let me explain you how I did it. And also it is based on the experience. So that is now my own experience, that the most successful projects as a product developer, which I did, we ended up never doing what the client originally asked us to do. And so what we ended up empirically by learning by doing, we ended up having something like 4 to 5 principal phases. The first phase was, so you are asked to design something, so you get a list of requirements.
Yeah, get the top level requirements from the customer.
And then, so you analyze them. But then after analyzing these requirements, with the input you have, you empathize with the field. You discover, you play, it's like, like a child building sandcastles. You don't have a blueprint. You just play with the sand. You say, how can I shape it? How big of a tower can I build? And so on. So it's a playful element. And after this discovery,
but in that playful element, from an engineering perspective, do you build some basic tools you can play with, so to say? Get some numbers or? Yeah,
you work. So in product design, you communicate with sketches and prototypes. So it could be that you take cardboard and tape, but rather than writing a document of ideas, you explore the physical space of an object, whether it's a mechanism or an artistic design, it doesn't matter. But you very quickly work with something physical, but it is it is more a working model than a prototype. So it's also learning to express ideas in 3D space rather than in words. Then basically, so first you analyze, then you empathize, you discover, and with all that knowledge, so let's say the sandcastle building, you are then able to reformulate the task, what you are asked to do. And as you reformulate it in your own language, the customer suddenly is astonished and says, now that you reformulate it in your language, I'm realizing that I completely forgot principal elements, or I realize that there is a conflict, that cannot be resolved. So this first iteration is very helpful. And as you are expressing requirements through physical models and sketches rather than through lists and figures and numbers, you really help to with your customer. You help to make out of an ill-defined problem a well-defined problem.
So that this is constant contact with your customer, constant negotiation. You could say that.
It's a creative negotiation. A constructive, creative negotiation. Okay. And then based with these new requirements, you are then able to start something which is then a bit closer to a normal development project, but still, even there, you can at the later stage always loop back. It can always be. So it is a design thinking is a process. You open up and you close down and you open up again.
So it's a really iterative process.
Yes. Yeah.
Okay, clear. what are common visualizations of such a process? Can you give some examples?
Yes, I can. So there's two visualization which I like a lot. There's one which was developed by Frog Design. Frog Design used to be a while ago a very famous design studio. So it is here. You see basically this pulsating line. You see basically you're at the starting point. You see the discovery phase where you really open up. You go really, really broad. And then from this, as you reformulate the requirements, you narrow down. Then you start in the design phase, you still open up. And as the further you go, the less you want to open up, because the further you go down and you open up, it becomes really expensive. But many classical engineering projects start here, and this original phase is the principal element. And then you deliver and deploy, and then you. Another also often seen visualization of the design thinking approach is, amongst others, proposed by Stanford University, and these are the key elements which you find in their approach is these 5 phases. You first empathize. So empathize is the same like discovery in the previous. Then comes the definition. It's the starting point of the design, and then comes the ideation phase as a principal element of the design. And then prototype and test. So it is a bit analogous. It's a similar approach, just visualized in a different way. And you find both visualization have a merit in understanding the design process approach.
Okay. You mentioned this topic, ideation. Can you elaborate a little bit on that? How do you do that? Because that seems to be the pinnacle, the key point in the process.
So the ideation, so there's a whole array of ideation techniques, and which one you actually want to use, it's also something, it depends on the topic, and depends how you work as a group. So first, maybe the 3 elements which I found really valuable are what we mentioned before. Think with prototypes. So take some foam, cardboard, something, and make very quickly something physical. It helps everybody to trigger a discussion in a good way. The second best solution is think with sketches. Don't talk and write, but sketch. Because everybody in the DSE is designing an object at the end of the day, so it should be able to very quickly to sketch it. The other thing, a known technique in design thinking process to develop requirements is to use personas. So rather than thinking what should this object do, think of a typical client as a person. So last year I supervised or I coached a project. They were developing a personal transport vehicle. So we together with the students developed personas like, I don't know, a young mother that has a business, a senior lawyer, an executive, like real people with a real CV, and we think, how does the object work with these people? And out of these stories, it's through storytelling, we discover requirements. So that's also a nice ideation technique. And then there is for the pure idea generation, there's a couple of processes. There is, for example, if you think you don't have an idea, you can think of the worst possible ideas. Basically, what are the ideas which are really a killer which make the project fail? You formulate those, and then once you formulated the worst possible ideas, you can invert them, and then you have the best possible ideas. Or there is a technique called Scamper. Scamper stands for substitute, combine, adapt, modify, put to another use, eliminate, reverse. It's basically ideation through combination of existing knowledge in various ways. And then there is, in terms of brainstorming, or idea generation, there's a classical brainstorm, which is maybe known to more students, where You sit down, you collect ideas without judging them, and then at the end you put them together or combine them. Brainstorming is a group process. You can also do a brain dump. Brain dump is a brainstorm individually, so you individually collect ideas and then bring them together. There is a technique, a brain write. You write or sketch and pass on. Basically, it's a playful element. Or you have a brain walk. For example, you say, my design object has maybe 5 different aspects. You make 5 stations, and for the 5 stations, you let people move from station to station, and then a way is also you challenging an assumption, basically saying that something is either not possible or not true, that can also be a way to provoke new ideas. And also more known is doing mind maps, graphical representation of relationships. You can work with analogies or use provocation. Also, provocation is also a bit a disruptive way to trigger ideas.
Okay.
But so there's a couple of these are more like techniques that can be helpful to, rather than sit together, say, okay, count on 3 and let's have good ideas now.
Okay, thanks. Last question for today. In another video, we speak about system engineering as an important tool in the design process. Mm-hmm. This is also an important tool in the creative process.
Yes.
Is there a contradiction, or do they add up to each other? How do you see that?
It depends what phase of the project you are. If the more disruptive your project is and the more possibly ill-defined your project is, the more you benefit in the early phase from the design thinking process. Once the things are lined up and you are rather confident that you're not missing substantial elements in your design assignment, then I think the power of the systems engineering approach can be really deployed to full strength.
Okay, thank you very much for this insight in design thinking.
Thanks a lot.